Okay, so the next thing we're going to learn in our factoring unit is how to factor trinomials that are in this form, x squared plus bx plus c. So 3 terms and look like that. All right, so that's our learning target. As we get going today, I want to review some of our multiplying integer rules. So let's just kind of review what we know about multiplying, right? If I multiply 3 times 5, in other words, a positive number times a positive number, I end up with a positive number. So that you know, right? Okay, well, what if I multiply a positive number times a negative number? So 4 times negative 6, you get negative 24, so you get a negative number, okay? And all right, how about this one? If I multiply negative 7 times 2, so a negative times a positive, I also get a negative number. And then finally, if I multiply a negative times a negative, I get a positive. Okay, so these are our rules. Basically, if the signs are the same, so notice here, positive and a positive, we get a positive answer. Or like this green one here, both a negative, then I get a positive answer. So if the signs are the same of the numbers you're multiplying, you'll end up with a positive answer. If they're different, in other words, one of them is negative, like the one in pink and the one in red there, then you're going to get a negative answer. So that's kind of just a quick review of our multiplying integer rules. That's important for what we're going to do today. Okay. So remember, distributive property is multiplying, and then if we factor, that's kind of going backwards. So if I use the distributive property and I say I want to figure out what this is, in our last unit we talked about how to do this, right? We said x times x, and then we did this, x times 5. So x times x gave us x squared. Oops. Gave us x squared. And then x times 5 is 5x. All right. Now, if I took and did 2 times both of these, okay, we got 2 times x is 2x, and then 2 times 5 was 10. And then we combined like terms, and you'd say, oh, these terms in the middle look the same. So we ended up with, our answer was x squared plus 7x plus 10. Okay, so that was the distributive property. We did that last unit quite a bit. So today what we're really doing, though, is we're going to take this and we're going to work backwards. In other words, I'm going to give you a polynomial that looks like this, and we're going to go back into this form. And this is called factored form. That's completely factored. Now, a couple things to notice. Notice there's an x here and an x here. That's so I get x squared. Okay? Well, how do I figure out what 2 numbers go here and here? Well, you might notice a couple of things, right? 2 times 5 is 10. 2 plus 5 is 7. So that's kind of a key thing. So today we're going to take something that looks like this, and we're going to work backwards, and we're going to kind of work with some of those things that we just mentioned. So really, what are we looking at? We're looking at 2 numbers. In order to factor this, we want to say 2 numbers that multiply to be this c term here, this thing right here, okay? And in that case, that was 10. So we want 2 numbers that multiply to be 10, but also add up to be b. In this case, that would be 7. So 2 numbers in this case that ended up multiplying to be 10 and also adding to be 7 were 2 and 5 in those 2 green numbers. So that's what we're going to do, and that's how we'll set it up. So one thing that you can expect every time is that your answer is going to look, it's going to look like this, okay? A couple of binomials, both starting with an x, okay? All right. All right, so we're going to factor this trinomial, and this trinomial looks like this, right? It says x squared plus 11x plus 24. And now, one thing that I do know is that when I factor this, this will be a couple of binomials. And I know in order to get the x squared term, I'm going to need an x in each of the beginnings of both of those binomials. Okay, so now I have an x and an x. Now, next, I need to figure out numbers that multiply to be this number, but add up to be this number. Okay, so we're going to write that out. Let's, numbers, so we'll say factors of 24. So remember, factors of 24 are just numbers that multiply to be 24. Now we want numbers that multiply to be 24, but add up to be this right here, 11. So we want it to add to 11, okay? Actually, I'm just going to write 11 here, and we'll put a little plus sign up here. We want it to add to 11. Okay, so now you want to write out numbers that multiply to be 24. If you're not great at that, you could also use your calculator, or you could maybe use your multiplication chart that I put in earlier this unit. You might want to pull this up and just look for numbers that like multiply to be 24 wherever you see a 24, and you can write those down. So like here would be 1. And that's one way to do it. Now, if you're good with your multiplication chart and your table up to a certain amount, you go ahead and use that. But I'm just gonna kind of write down some of these, so hopefully you feel like, oh yeah, that's so. Well, 1 and 24. Well, that's an easy one. Another one would be 2 and 12. Okay, 3 times 8. 4 times 6. And that's it. It's all those ones in the reverse order too. But those are the major ones. Now, those are the factors. Now I want the pair here that's going to add up to be 11, right? So if I add these numbers here, 1 plus 24 gives me 25. Okay. 2 plus 12 is 14. Okay, now 3 plus 8. Ooh, that's 11. That's what I wanted. That's going to be my answer. I'm just going to do this other one just to make sure we have them all written down. But notice the only one that adds up to be 11 is going to be my answer. So that's this pair right here. So we're going to use 3 and 8. So it multiplies to be 24 and adds up to 11. It's got to do both of those things. So here, what does this mean? Well, I'm going to put a positive 3 here, and I'm going to put a positive 8 here. Does it matter if you flip these around? No. Just make sure you have a positive 3 and a positive 8. Don't put commas here. We're not doing that. Notice this is plus 3 and x plus 8. So really, again, you want it to look like what we talked about here. We want it to look like this. So 2 binomials when you multiply them together. So there's my answer. My answer is x plus 3 times x plus 8. Now, if you distributed this out, in other words, multiply these together like this, you should end up with this back, okay? That's a good way to check if you're on, I guess we'll just leave that there. Okay, now, so that's how you do that. And again, if you're really good with this in your head, you might not need to make this table. But I would suggest that you do it at the beginning to get used to it. So I've made that table just kind of for every one here, but you might run across stuff faster. So I'm always just going to start by, I know that it's going to look like this. Okay, a couple binomials, and I know every time I factor something in this form, x squared plus bx plus c, I have a couple of x's here. Okay, so that's a good way to start. Now I just need to figure out what goes here and here, and I'm good. So now this time we have factors of 56. Again, that means numbers that multiply to be 56, and we want them to add to be 15. Okay, so you could write out some of these. You know some of them are going to be pretty easy. So like, 1 and 56. You know it's even, so maybe 2. And if you're not sure what other things that go in there, so you say 2 times what is 56? Well, use your calculator. And let me just pull that up. Right, so just go 56 divided by 2, work backwards, and you go, oh, that's 28. So I say, all right, 2 and 28, 4 and 14, go in there. There's a number of them, but 8 times 7, okay? And if you add these up and you can't find one, maybe you are missing a pair. So let's just start with these and see if we've got one. So 1 plus 56. Again, maybe you don't write all this out. You just go, oh, that's 57. Nope. 2 plus 28 is 30. Nope. 4 plus 14. Nope. 8 plus 7. Ooh, yep. There we go. That's the pair that I want to use. So I'm going to write, notice they're both positive, so I'm going to put plus 8 and plus 7. So my answer here would be x plus 8 times x plus 7. That, if I were to multiply this back this way, would give me x squared plus 15x plus 56. So we've just factored x squared plus 15x plus 56. Cool. Okay. Now, here's where you have some issues, is where negatives come in. So this is where you want to be careful. And again, we're looking for numbers that multiply to be negative 18, but add up to be negative 3. We're looking for them to add up to be negative 3, and you want to take your time with this. So when you do factors of negative 18, I like to start with just the positive versions first. Okay. So these are numbers that multiply to be 18. Now, I know that in order for me to get a negative 18 when I'm multiplying, one of them has to be negative. So like, I need one of them to be negative. So now it matters which one's negative. Now, if you're looking at these and you're saying, how could I get this to add up to be negative 3? There's no way I could get this to add up to be negative 3. Same with this, because this one is 17 units apart and this one is 7 units apart. So that's too far apart. This one is 3 units apart, so I'm going to be using that pair because then I could get to maybe negative 3. Okay, so how? Well, I have to figure out where do I want to put the negative. Is it going to go here? Well, negative 3 plus 6. If you go negative 3 plus 6, that gives you positive 3. Close, but not quite. So that means I might need to put the negative on the 6 instead. So now I have 3 plus negative 6. Well, that's negative 3. Okay, if you're not sure, use your calculator. But that's then the pair that I want to use. And so you got to figure out, where does the negative go? Which pair is it going to be on? Or which one of those pairs is going to be on? So in this case, it's going on the 6. So that gives me the pair that I want. So I'm going to write my 2 binomials, and now I want to use this one because it adds up to be negative 3. So let's see. That means I have positive 3 here, and this is a negative 6, so I'm going to put negative 6 here. If you flip these around, that's okay as long as the sign stays with it, meaning the 6 has to be negative, or it's not going to work. Okay, so that's something to be aware of. A little trickier when you've got negatives involved. So take your time. Now, if you're really good at this, you might not need these charts, right? You might be like, oh, I got this. I don't need this chart anymore, okay? So here, and maybe that's the case, you say, oh, I got this. I don't need it, and I'm good. But maybe you just write down a few. What are some numbers that multiply to be 32? So let's say you come across a few, you write these down, and then you're trying to figure out what's going on. See, I can kind of use in this chart anyways. So now I could say, hey, ooh, that equals 12, right? If I add those two together. The problem is it says negative 12. So I'm trying to get these to add up to be negative 12. In order for that to work, how can I do that if this is positive? Well, remember, 2 negatives multiply to be a positive. So this is a little bit of a sneaky one. This would be negative 4 and negative 8. If you add those together, that gives you negative 12. So it's one of those things to just be aware of. Is in this case, I've got a positive 32 and I have a negative 12. That's an indication that I'm going to need both of these numbers to be negative. So a little bit of a sneaky one. Be aware of that. The positives and negatives matter, otherwise it's wrong. So make sure you're taking a close look at each number, whether they're positive or negative, and consider that when you're factoring. And that's how you factor polynomials in the form x² plus bx plus c. Okay? You have an assignment. Write it into your planner. It's called Factoring x² plus bx plus c worksheet. And then when you're done, check it off and turn it in. All right? Have a good one.